The telescope is one of humanity's most important scientific instruments, unlocking a view of the cosmos that had once been hidden to the naked eye. This invention transformed our understanding of the universe, revolutionized astronomy, and redefined humankind's place in the cosmos. The journey of the telescope, from its mysterious origins in early optical experiments to the colossal space observatories of the modern era, is a story filled with curiosity, conflict, innovation, and a relentless pursuit of knowledge. The telescope has become a symbol of exploration and scientific progress, allowing us to see far beyond what was once thought possible. Even before telescopes were conceived, human beings had long gazed at the heavens in awe. Ancient civilizations like the Babylonians, Egyptians, Greeks, Chinese, and Mayans tracked the movements of stars and planets. Without magnification tools, early astronomers built complex calendars, navigated the seas, and laid the groundwork for celestial science using only careful observation and simple tools like sighting tubes and armillary spheres. These cultures understood that the sky followed patterns, but their view of the heavens remained limited to what the eye could perceive unaided. The idea of manipulating light to enhance vision goes back to antiquity. The use of glass to bend and focus light had been explored as early as the 1st century BCE. In ancient Alexandria, scientists experimented with curved glass and water-filled vessels to magnify objects. The Greeks, particularly thinkers like Euclid and Ptolemy, studied optics, understanding how light traveled and could be reflected or refracted. These early observations would later become the foundation for modern optics. However, it was not until the late Middle Ages and the Renaissance that real progress was made in lens making and magnification. The development of eyeglasses in the 13th century marked a turning point in optical technology. In northern Italy, skilled artisans in cities like Venice and Florence began crafting convex lenses to assist the elderly with reading. These lenses were set into frames and balanced on the nose, improving vision for millions and laying the groundwork for future optical devices. By the 15th and 16th centuries, lens making had become a refined art, with craftsmen across Europe experimenting with combinations of convex and concave lenses for various visual enhancements. The story of the telescope officially begins in the early 17th century in the Netherlands. In 1608, a Dutch spectacle maker named Hans Lippershey is widely credited with the invention of the first refracting telescope. According to historical accounts, Lippershey discovered that when two lenses were placed at a specific distance apart, distant objects appeared much closer. He applied for a patent for this device, which he described as a kikker or looker. However, there is still debate among historians as to whether he was truly the first to create such a device. Other spectacle makers, including Zacharias Jansen and Jacob Mettis, claimed similar discoveries around the same time, indicating that the telescope may have been an idea whose time had come. The invention quickly spread across Europe. News of this magical instrument reached Italy, where it caught the attention of Galileo Galilei. In 1609, upon hearing of the Dutch invention, Galilei constructed his own improved version of the telescope. His first telescope magnified objects 3 times, but through further refinement, he was able to build instruments that offered 20 to 30 times magnification. Galileo's version used a convex subjective lens and a concave eyepiece, a design known today as the Galilean telescope. What set Galileo apart was not just his craftsmanship, but how he used the telescope. Instead of viewing it as a novelty, he saw it as a scientific tool. In 1609 and 1610, Galileo made a series of groundbreaking astronomical discoveries. He observed that the moon had mountains and craters, challenging the Aristotelian idea that celestial bodies were perfect spheres. He discovered 4 moons orbiting Jupiter, now known as the Galilean moons, which contradicted the geocentric model of the universe. He also observed the phases of Venus, the rings of Saturn, and countless new stars in the Milky Way. His publication, Sidereus Nuncius, in 1610 shook the foundations of science and theology alike. The Catholic Church, which held that Earth was the center of the universe, was not pleased with Galileo's findings. His support for the heliocentric model, proposed by Copernicus, brought him into direct conflict with religious authorities. Galileo was tried by the Inquisition in 1633 and forced to recant his beliefs, spending the rest of his life under house arrest. Despite this, his work laid the foundation for modern observational astronomy and demonstrated the power of telescopic observation. Following Galileo, other scientists built upon and improved the design of the telescope. Johannes Kepler, the great German astronomer, published a theoretical description of a new telescope design in 1611. Unlike Galileo's telescope, which used a concave eyepiece, the Keplerian telescope used two convex lenses. This configuration provided a wider field of view and better image quality, although it inverted the image. Kepler's design would become the basis for most future refracting telescopes. The 17th and 18th centuries saw rapid advancements in telescope design and astronomy. The biggest challenge to refracting telescopes was chromatic aberration, a distortion caused by the different wavelengths of light being refracted at different angles, resulting in colored fringes around objects. This problem limited the clarity and magnification of early instruments. In the 1660s, English scientist Isaac Newton developed a solution to chromatic aberration, the reflecting telescope. Instead of using lenses, Newton's telescope used a curved mirror to gather light and focus it into an image. The Newtonian reflector, as it came to be known, avoided the color distortion inherent in refractors. Newton's design, published in 1672, marked a turning point and led to the widespread use of mirrors in telescope construction. The 18th and 19th centuries witnessed the construction of ever larger telescopes. In Ireland, astronomer William Parsons, the 3rd Earl of Ross, built the Leviathan of Parsonstown in 1845. This enormous reflecting telescope, with a 72-inch mirror, remained the world's largest telescope for over 70 years. It revealed spiral structures in galaxies and helped shape early ideas about the nature of the universe. Meanwhile, advances in lens making and optical theory allowed refracting telescopes to continue evolving. In 1897, the Yerkes Observatory in Wisconsin unveiled a 40-inch refractor, the largest of its kind ever built. These massive telescopes enabled astronomers to study planets, stars, and nebulae in unprecedented detail. At the turn of the 20th century, telescopes began moving into the realm of astrophysics. Scientists were no longer content with simply observing celestial bodies. They wanted to understand their composition, motion, and life cycles. The introduction of photography and spectroscopy transformed telescopes into powerful scientific tools. With photographic plates, astronomers could capture faint objects invisible to the eye and record long-term changes in the sky. Spectroscopes allowed them to analyze the light from stars and galaxies, revealing their chemical makeup, temperature, and motion through the Doppler effect. Perhaps one of the most significant milestones in telescope history came with the construction of the 100-inch Hooker telescope at Mount Wilson Observatory in California. Completed in 1917, this instrument allowed astronomer Edwin Hubble to make one of the most profound discoveries in cosmology. The universe is expanding. By studying the redshift of galaxies, Hubble concluded that the farther a galaxy is from Earth, the faster it is moving away. This laid the groundwork for the Big Bang theory and revolutionized our understanding of the cosmos. The 20th century also marked the age of radio telescopes. In 1931, American engineer Carl Jansky accidentally discovered radio waves coming from the center of the Milky Way. This led to the birth of radio astronomy, which uses antennas instead of lenses or mirrors to detect radio emissions from space. Instruments like the Arecibo Observatory in Puerto Rico and the Very Large Array in New Mexico provided insights into pulsars, quasars, and cosmic microwave background radiation. As the space age dawned, telescopes began to leave Earth altogether. Ground-based telescopes are limited by the atmosphere, which distorts and absorbs certain wavelengths of light. In 1990, NASA launched the Hubble Space Telescope into low Earth orbit. Free from atmospheric interference, Hubble captured breathtaking images of deep space and made countless scientific contributions, from measuring the rate of cosmic expansion to discovering exoplanets and mapping distant galaxies. Hubble's success inspired the development of other space-based observatories, including the Chandra X-ray Observatory, the Spitzer Space Telescope, and the recently launched James Webb Space Telescope. The JWST, launched in 2021, represents the pinnacle of telescope technology. With a 21-foot gold-coated mirror and advanced infrared sensors, it is designed to peer deeper into space and further back in time than any instrument before it. JWST promises to explore the first galaxies formed after the Big Bang, study the atmospheres of distant exoplanets, and refine our understanding of star formation and galactic evolution. Today, telescopes come in a variety of forms and serve countless purposes. Amateur astronomers use backyard scopes to observe lunar craters and Saturn's rings. Ground-based giants like the extremely large telescope are under construction in Chile, promising to revolutionize our view of the universe once more. Adaptive optics and interferometry help overcome atmospheric distortion, enabling sharper, more detailed views of the night sky. Digital and robotic telescopes now survey the entire sky, scanning for supernova, asteroids, and other transient phenomena. New projects like the Vera C. Rubin Observatory aim to create time-lapse movies of the cosmos, revealing how the universe changes over time.